In section 5 of chapter 7, we're going to talk about compound interest. And let's just start out by looking at this in a pictorial fashion. Suppose you have a pile of loot and you take it to the bank, stick it in the bank. After a period of time, you get some interest on that pile of loot. And it becomes a smaller pile that is your interest. So you add this interest to your original or your principal, and you get a larger amount that you have in the bank now. It's incrementally larger, but it is larger nonetheless. So more time goes by, and now it's time to accumulate some more interest. Since your pile is a little bigger, your interest is also a little larger than what it was before. Again, you of course add this. It still accumulates in your bank account, and now your pile is even larger. Let's do this one more time. You have the slightly larger loot pile. You add interest based on this slightly larger loot pile, and this results in an even bigger final amount. This process is essentially compound interest. Let's fill in some equations that we're familiar with. So this would be your principal. To that, you're going to add interest, which is your principal, times your interest rate, times your time. This will equal your final amount. So if you look at this equation, of course, we could pull the P out. So P times 1 plus RT is another way of looking at that relationship. So that's what your amount equals. So if that's your amount, keep in mind this amount is brought down the next time we do our interest to here. That means that this pile now is P times 1 plus RT. And to calculate the interest on this new pile, you will need to take this value as your new principal. It's a little larger than P because it's multiplied by this value, but it's still our new principal. So we start out with this value, and then we multiply it again by RT. Now, if you look at this and use our distributive rule for multiplication, I can pull this P times 1 plus RT out. So I'm pulling this value and this value out, and what we're left with is 1 plus RT. And you'll see if you take this and you multiply it back through, you have to first multiply it by 1, and then you have to multiply it by RT. You're going to end up with this. With this statement over here. Finally, we do this process a third time, and we end up with a relationship like this for our principal now. So it just keeps getting bigger and bigger. So then we have to take our new principal and multiply it again by RT to determine our interest. So this here is our third period interest, probably a year. So this then equals, I could simplify this by pulling again this common term. I'm going to group this whole thing, and I can see that it's the same as this. So I'm going to pull that out like such, and what I'm left with is 1 plus RT again. Let's square bracket this end. So notice, while I'm doing this compounding process and I'm accumulating more amount, that in the calculations we do, there's a pattern here. So initially this is P to the 1 plus RT. Let's just say raised to the power of 1. Now this is P to the 1 plus RT raised to the power of 2. That's after the second round of interest is accumulated. And after the third round, look here, we get P times 1 plus RT cubed. So this is the equation associated with compound interest. Let's throw some numbers in so you can see what I'm talking about. So let's suppose that you invest $1,000 at 8% over 3 years. And let's do our simple interest calculation that we learned previously. So we have some amount. Our interest is PRT. Off of our principal. So we start with an amount, we have a principal, and we add some interest, PRT. So this will end up being, we can pull the P out here, and if I put the numbers from above in, I get a result something like this. And if I do the calculation, I end up after 3 years with $1,240. So I accumulated $240 in interest over 3 years using a simple interest calculation approach. Now let's do the same example with compound interest. In other words, I'm going to take into account that my principal is growing in my calculations. So my first year calculation is going to be the same. I guess I'll do it here. We have 1,000 times 1 plus 0.08 except since it's only for a year, this is going to be 1 instead of 3, and our result here is $1,080. Okay. So now I'm going to take that $1,080. We've accumulated some interest on it, and I'm going to use that as in my next compounding period as my principal. So I'll have 1,080, calculate my interest times 0.08, and I end up with $1,166.4. Okay, scrolling down. So now I'm accumulating more. So this is $1,166.4. This is what I've accumulated now in the past 2 years. And so I have to do one more interest compounding here. Multiply the new principal by RT. Add this to our 1,166.4, and we end up. So then after doing this calculation, taking 1166.4 plus 1166.4 times our RT, so this is the new principal times to figure out what our new interest is, we end up with $1,259.71. And if you compare that to what we got from the simple interest case of $1,240, you'll see that you've made a little bit more money. And that's over 3 compounding periods. So you've accumulated interest over 3 years, and we've calculated that interest based on the accumulation 3 times. Now, banks will also compound your money at a higher rate. So you can not just compound and do these calculations annually. You could do it at a higher rate. You could do it monthly. You could do it semi-annually. You could do it quarterly. You could do it daily. And in fact, you could do it continuously, but that's going to go beyond the scope of this class. But you could do it like that. And the more times you compound, the more money you're going to end up with in the end. So when we look at these simplified relationships over here, and you see this pattern, we could actually write an equation for compound interest, so we don't have to do this process like I did up here, the long drawn out process. We can just have one equation that we solve. And our compound interest equation is going to look like this. So our final amount equals some principal multiplied by 1 plus r over n raised to the power of nt. So here A equals your final amount, P equals your principal, R is your interest rate, as usual, and N is the number of compounding periods in the course, say, of a year. That's if your interest rate is an annual interest rate, which we'll be doing in this class. Number of compounding periods, which we'll be exclusively doing in this class. So, when you have annual compounding, the value of n equals 1. For semi-annual, n equals 2. For quarterly, or every 4 months, n equals every 3 months, I'm sorry. Quarterly, every 3 months, n equals 4. There's 4 quarters in a year. And for monthly, n equals 12. The rest of these values are the same as we used before.